Okay. Can people hear me okay? Okay. Well, yeah, hi everyone. I'm Brennan, for those of you who don't know me. I'm an engineer at Gridspace and the team lead of our call.chat team. What that means, you will find out during the course of this presentation. I have a background first actually in classical languages, and then I did a master's in computer science with a focus in AI at Stanford. But yeah, so today I'm going to be talking about what it means to be agentic for me and for us at Gridspace, and how we've used that definition or opinions on agentic AI to start developing a new product. So before I talk about what it means to be agentic, I first want to discuss the history of the word agent, specifically in the field of computer science. It's actually been around for quite a while. So if we go back to the 50s, John McCarthy and Oliver Selfridge first proposed and defined the idea of an agent as a system that could receive goals and execute appropriate computer operations on its own. Then, in 1977, Carl Hewitt developed the actor model, and while he didn't actually use the word agent, he described an actor as a self-contained, concurrently executing object with internal state and communication capabilities. Then in the 80s, expert systems marked an AI boom, focusing on encoding expert knowledge into rule-based systems. Deep Blue is probably the most famous example of this. It was the first chess-playing supercomputer to win against a reigning world champion. In 1995, Stuart Russell and Peter Norvig first published Artificial Intelligence, a modern approach, which is considered to be the best and most popular AI textbook. And in it, they actually formalized a definition of a computer agent. And then more recently, in the 2010s and 2020s, we've seen significant advancements in integrating machine learning models into AI agents, particularly in areas requiring strategic decision-making and complex reasoning. For example, in games like Go and poker, you may have heard of AlphaGo. But going back to the 90s and Russell and Norvig's definition of what a computer agent is, they defined it essentially as, of course, an agent is just something that acts, it does stuff. My classical languages background loved the callback to Latin. But yeah, of course, all agents and all computer programs do things, but what makes computer agents different is specifically that they operate autonomously, perceive their environment, persist over a prolonged time period, adapt to change, and create and pursue goals. But how do we get from this definition of a computer agent to the concept of agentic AI as it's being discussed today? Obviously, agent just means agent-like, but in the context of LLMs, we can turn this into a more precise working definition. So, in my opinion, an agentic AI system is one that is stateful. In other words, it should have persistent long-term memory to recall previous events, such as interactions with the user, interactions with the outside world, and knowledge of the things that it has done in the past. The second thing is that it should be able to learn. This is important because it should be able to use its persistent memory to learn and adapt over time to better handle the tasks that it's given. This is kind of the difference between when you think about how large language models learn, it's more that they're being actively trained by people. The idea of an agentic AI system is that it should be able to learn on its own without that direct human intervention. The third thing is it should be able to plan. Task planning and execution is obviously a kind of crucial part of what an agentic AI system should be. We want them to do things for us. So these systems need to be able to look ahead and plan to execute complex multi-step tasks. And finally, it should be able to use tools. This one is kind of less obvious from the definition, but I think if we look at the stipulation that they should perceive their environment, tools is really how these agents can do it. For example, if they need to learn information about the world, learn information from a specific person that only exists in their head and isn't online, they might need a tool to like make a phone call to that person or make a tool to perform a Google search. So great, now we have our working definition of what an agentic AI system looks like. But how is it relevant to us at Gridspace? For those of you who don't know, Gridspace, here at Gridspace, we're a speech and language tech company that analyzes millions of call center conversations every year. We're also the builders of Grace, an AI-powered virtual agent who handles customer service calls for businesses in a variety of industries, like all the way from healthcare to insurance and banking. And while Grace excels at handling live, structured phone calls, there were some interesting challenges that have arisen that we realized could best be solved by these more agentic AI systems. So the first challenge was Grace currently operates in a single modality. What this means is right now, Grace can only converse with a human over the phone, pretty much. And so this is a two-way synchronous conversation. Whatever the virtual agent needs to do for the person that's on the phone with it has to do that in the context of the phone call and in that time frame. But what if we want to include multiple modalities or multiple methods of communication, such as text or email? You can imagine a couple scenarios where this might be helpful. For example, say person A calls person B for help, but maybe person B actually has to send them information over text that's relevant to the conversation they're having. This obviously introduces a lot more challenges because it involves maneuvering between synchronous and asynchronous communication. So the second challenge we saw was that Grace currently doesn't really have a long-term dynamic memory, besides from like what we as her authors like manually give her or like a customer gives her. So if we think about this example, like say Grace is calling a patient because Grace is working for a doctor's office and she's trying to help a patient set up an appointment. She might say, what days of the week work best for you? And maybe the person is like Mondays and Thursdays. And then a month later, the agent needs to call the same person to schedule another appointment, and they have to ask this again. And again, it's still Mondays and Thursdays. But what if we want to give Grace long-term memory? We can see how this would help here. So again, let's say to start, Grace has to ask someone what days of the week work best for them. And they say Mondays and Thursdays. But this time we put it in a search index or a database so that 1 month later when we have to make the call again, we can pull that information from the database and the agent can reference it in the call. This is obviously like a simplified example, but you can see how there's a lot of potential to really save time and help with user fatigue. So how are we at Gridspace trying to address these challenges that we've observed in our existing product? The answer is call.chat. So what is call.chat? Call.chat is our very new personalized agentic AI secretary that can do a bunch of things for you. First and foremost, it can plan and execute complex tasks on your behalf. It has a range of tools that, like all the way from making and receiving phone calls for you, sending and receiving texts and emails, to searching Yelp, searching Google, interacting with your calendar and contact database. As you can imagine, there's a lot of different applications to using all these tools. For example, you could ask call.chat to call a bunch of vendors and ask them for quotes and give you the best one. You could ask it to handle incoming requests from your clients, either by phone, text, or email. Or you could use it to coordinate a large business dinner, just to name a couple examples. Secondly, call.chat remembers and learns from your previous interactions, and it's also able to suggest new tasks based on your history and preferences without being explicitly prompted. So going back to the 4 key features we talked about for what makes an agentic AI system, let's talk about how call.chat specifically handles each of these. Oh, yeah, just remember these are the 4. So call.chat is stateful. How we do this is it utilizes the context window and dialogue history to sustain long-term memory. This is further supported by retrieval augmented generation. Essentially, this means that the agent is able to look up information in a search index to help with text generation and with task completion. If we look at this example, we have a user who's texting their call.chat agent, and like the example I just mentioned, they're saying, I need a headlight replacement. Can you find some car mechanics near me and get me like the best one? So what call.chat first has to do, it has to think. So it's like, okay, great, the user requested mechanics near them, but like, where is that? I need their address. So it asks the database, and it's like, do we have their address? The database says yes, and it sends it back. And then the call.chat agent can respond to its user and say, great, okay, I have everything I need. I'm gonna do this task for you. And then off it goes to do the task. Number 2 is an AI agent has to be able to learn. So call.chat learns from your preferences and previous tasks to suggest new tasks that it can help you with. So in this instance, unprompted, call.chat is looking through its history and thinking about the types of things it could help its user with. In this instance, maybe the user's a real estate agent, and call.chat is like, okay, my user recently held a viewing for an open house. Maybe I should offer to send a feedback survey to everyone who attended. So then it can suggest that task to the user approves, and also specifies maybe some more detail that they would like. And then again, the agent sends that task off. But now, how are these tasks actually planned and executed? Call.chat has a specialized task engine that adheres to the following core principles. Number 1, the agent should first and foremost always look ahead of its capabilities and decide whether it can or cannot complete the task. It's really important that the agent knows its limitations so it doesn't attempt to do something that it just can't do, or like deceive the user into thinking it can do something that it can't. Number 2 is that it should plan the individual steps it will need to achieve the larger goal. Going back to what Cyril was saying about like breaking down tasks into like smaller chunks, like this is like really crucial to making it succeed. Number 3 is that it will choose from a large list of generic procedures that distill real human expert knowledge. In other words, the agent isn't allowed to just go off and do whatever it likes. It has to pick from a list of predefined tasks with like explicitly written generalized steps. So this affords the LLM latitude to make rational decisions, which is what we want them to do because that's what they're good at, but it still keeps it on a tight leash. And then finally, we expect our task agent to continually evaluate its progress throughout the task execution to make sure it's not going off track anywhere. And with that, I will show you a screen recording of call.chat in action. This is just a recording because it's kind of hard to show this live at the moment because you kind of have to wait like a couple of minutes for it to finish the task, and I think that's boring to sit here for that. But yeah, in this video, you'll see call.chat help me reschedule a meeting by looking at its attendees and coordinating a new time based on my availability with the other attendees of the meeting. And I'll try and narrate it as we go. If this loads. Okay, yeah. So this is my call.chat agent I'm texting. I say, I have a doctor's appointment that just came up. Tomorrow at 10 a.m., can you like reschedule for a time when everyone is free? And then call.chat should respond. I might pause this, it's going too quickly. But yeah, it says, okay, great, like I'll do that and let you know. And so for some reference, this is what my calendar looks like the day I'm asking it about. There's like a team meeting at 10, and it looks like I'm free after 4, so we'll see. And those are the attendees of the meeting. They're all my other email addresses, so they're gonna refer to all the attendees as Brennan, but they're different people. Great, it identified the right meeting. It says I have my team meeting at 10 a.m. and that I'm free from 4 to 5. And so it says it's emailed both attendees to propose this rescheduled time. Great, and it will let me know when it has updates. So this is like the point of view now of attendee 1's phone. So they'll get an email from my call.chat agent proposing a reschedule for 4 to 5 p.m. And asking for a response. So attendee 1 is going to accept the new time. I got the time wrong. Great, and that sent. And now you can see that my call.chat agent has told me that, look, hey, I've got a response from attendee 1, and they said, great, they can do 4 p.m. Let's wait for the next person. So now we have attendee 2, who's also going to get a similar email. But this time, attendee 2 is going to say they can't make it. And then it should also update me about that. Great. Yeah, Brennan 4 is unable to make it, but you can proceed without them. And now it says it's going to update the calendar and will let me know when that's done. Let's see if it does that. Okay, and this point I want to bring attention to because this is really good. So I mentioned we're still very early stages of development, but right now our call.chat agent doesn't actually have a tool to update an existing calendar event. It can only make a new one. And so as you can see here, the agent identified that and it said, I can't do that, but like I can do this alternative solution. So this is really great. This is like what we want it to do. We don't want it to pretend it can do something that it can't. So yeah, I say, yeah, that's fine. And then finally, after a moment, it should make the new event. Great, yeah, sent me an update, and it's been created. Let's see if it actually did that when I go back to my calendar. Cool. And there it is, a team meeting all the way at the bottom. And if I click on it, you can see it's just myself and the one attendee that said they could make it and not the new person. So that's just one example of what call.chat can do for you. We're inviting everyone that's here today to try it out if you're interested. Yeah, all you have to do is just go to call.chat in your browser on your phone and just sign up and use this AILA 2025 code. And then I think in around like maybe 15, 20 minutes, you'll basically get a text to your phone from your agent when your agent is ready for you to use it. But yeah, if you're interested, can be a bit daunting because there's a lot of things it can do for you. You might want to try the following tasks as a starting point, but you can also come find me later if you want more ideas. But maybe you could ask it to search for a restaurant that's open and maybe call them and ask a question, like if they have vegetarian options. You could have it schedule to send an email for you in the morning, maybe something work-related. Or you could just like ask it to call your friend and harass your friend for you. And I can bring this back up, but yeah, that's it. Thank you. Any questions?
Hello again. I've already introduced myself, so I'm not going to do that again because we all have long-term memory. Good presentation. My question is that you mentioned that the agent is able to learn user preferences. What's the mechanism for it to maintain that sort of state of what the preferences are in the system? Like, how does it know what the user would prefer?
It's definitely like more like recency focused. Like it'll prioritize like more recent things that the user has suggested they prefer. So it's definitely kind of like over time, older history like is less prioritized. Yeah. Yes.
Right. So you mentioned that there was a list of resources that was more so that
Oh yeah.
Does the agent also look for new resources and suggest them to you for review qualification, or is that a separate information? Space are popping up all the time.
Mm-hmm.
So if I think I'm understanding your question, so right now the like list of resources it has is like predefined by like us as the builders. We don't have it right now like telling us to build more things like people have requested. But I mean, like, we definitely should. I think that's. No, not at the moment. Right now, it just has has access to all the resources that we've developed. So, yes.
I was just curious, like, what information they were accessed
In your
phone.
Yeah. It's a really great question. So right now, it's kind of just, for the most part, it's just limited to like what you tell it explicitly, like in this text channel, except for your contact list. But again, you choose to upload your contact list and your calendar. Besides from that, it doesn't have any other information about you other than like what you text like into the dialogue history, essentially.
Hi, so I have a question about scale. I'm working right now with a client who wants to buy everybody in the US, small business, and so he's looking to call maybe like 10,000 companies. So basically, they are for sale. Very easy, try to introduce himself and understand what is the state of the business. It was not only a discussion about the state. So where do you want to break and
Your question is how much it can scale at the moment. It's not been. It's like it was definitely architected so that it should be, but it has not been like heavily scale tested. I think we've got like a bit over 100 like alpha beta users right now. But like every agent is distinct. Like none of the agents for each user are connected to each other at the moment. So it kind of like, I think scale-wise, it's like per your own individual agent and like the memory that you've built up.
Does it currently account for like nuances in communication in the sense of like, can I respond to text in like emoji or with like different forms?
Yeah, you can use emojis, and it's like pretty responsive to any like format or like style of communication. You can send it images too, so it can analyze and parse your images as well, which is really helpful.
Can it help you deal with a nightmare customer service situation? Like if you needed to get an airline on the phone and we're on hold for hours, can it be a mediator between you and the company?
I like that question. That's really cool. So right now it can sit on hold. It doesn't have like a transfer to you option at the moment. I think that's a really cool idea, but it can like navigate IVRs and stay on hold, but then it will do the phone call. So like it will speak to the person after. It can't transfer back to you right now.
Hey, Brennan, this is Rohit. And I just want to know that you were talking about call.chat. I want to know how does it handle the ambiguity in text and context switching when a person is talking to call.chat?
Yeah.
How does it do?
Yeah, that's another good question. We've like really prioritized, like emphasized to our agents the importance of like clarifying and confirming. And so they can confirm before they start a task, like while they're executing a task, one of the tools is like confirm this information. So yeah, we really heavily try and emphasize that it can confirm with the user at any point before proceeding, if it's at all unsure. Yeah, great. Thank you.